Good morning, ladies and gentlemen. On behalf of Euroavia Aachen, I want to extend you a warm welcome and would say, that the second presentation of the Rotorthon before the winning ceremony is opened. So we are ready to take off.
Yeah, so first of all, we would give you a quick overview about what awaits you. First of all, we will introduce ourselves just really briefly, so you have a bit of a background on us, and then also Euroavia, the association we represent. After this, we will show you who the jury will be, because for a challenge, you obviously need someone to judge the results. And then also, before we come to the concepts of the groups, we will also quickly reiterate what the challenge was if you haven't been there last time, so you are up to date. The presentation of the results will always be split into two parts. First of all, the groups will come onto the stage and elaborate on their concepts they work on during the last days. And after this, there will be an equally long period where the jury will poke at the concept, tickle out the final details, and just ask a few additional questions.
Okay, so a few sentences about us. My name is Natasha Sekulic. I'm the president of Euroavia Aachen. I'm 19 years old, studying in my third year mechanical engineering at RWTH Aachen University. I finished my A-levels with 16, started studying with 16. Playing football, it's my passion. And joined Euroavia in my first semester at the very, very beginning. And I think it's your time, Jan.
Thanks, Natasha. So, as you can see, I'm 22 years old and also, like Natasha, in my third year of my bachelor's degree in mechanical engineering at RWTH Aachen University. But what I always find more interesting is how I got into what I'm doing now. So the passion for the aerospace sector and science. It's obviously started in school when I always loved maths, physics, chemistry, like in so many cases. And then after I graduated, also with an advanced level course in physics, I asked myself the question, what do you want to do with your life, with your career? And it quickly became apparent to me that I definitely would want to do something connected to space and like outer space. And then I asked myself whether I wanted to go on the fundamental side of things with something like astrophysics, or the engineering side, and apparently I opted for this one. And so I'm currently pursuing my bachelor's in mechanical engineering to then hopefully as a master's graduate in aerospace engineering. Then let's move on to a quick presentation about Euroavia Aachen.
So, what is Euroavia? Euroavia is a quite old student association for aerospace interested students. Euroavia was founded in Aachen in 1959. Now we are over 2,000 members in 42 states all over Europe and India and Egypt. So we are quite big. And what we do is we are organizing a lot of networking events, travels to ILA Berlin, Paris Air Show, excursions to companies such as Lufthansa, Airbus, everywhere. And we're doing also fair visits. For example, other local groups of Euroavia in Europe are also organizing symposia so that you can go there. For example, my last symposium was in Belgrade before the pandemic has started. So you have the chance to meet students all over Europe and networking, that's it.
That's our core issue, exactly. So now we already come to the part where we would like to present the jury. So if you would be so kind to stand up and also join us on the stage, maybe to just give a few words about yourself and your background. You will get a microphone in a minute. Bitteschön.
So it is working? Or?
It should be working.
1, 2. Okay.
Great.
I can't hear myself, that's the problem.
Oh, okay. Maybe then the receiver is not quite working.
So Hello everybody, so my name is Peter Müller. I'm the chairman of the European Helicopter Association. I'm a helicopter pilot myself. I started flying helicopters 1977. Besides having been a helicopter pilot, I had several posts in the helicopter operations, so as crew training manager, as flight operations manager. I'm still a flight instructor and a flight examiner. And I'm happy to be here today and to be part of the jury. Wish you much
Thank you
success.
for being here.
Thank you, Peter. My name is Clément Audard. I'm working for the European Union Aviation Safety Agency, EASA, which is a technical agency of the European Commission based in Cologne, just on the other side of the Rhine. So I'm passionate about aviation, and that's why I decided to study aviation and then to work in this business. I started with remote control aircraft by designing and building them and a bit later crashing them. Moving to paragliding for 25 years of paragliding, then gliding, moving to light aircraft, and the last things I was able to do last year, after having saved money for 10 years, is to pay myself an helicopter pilot license. So I'm now an helicopter pilot as well, and I really still enjoy aviation and flying after so many years.
Thank you, Clément. Pierre-Olivier Mathian. I'm Airbus, and I'm glad to be here today. My background, I'm an engineer. After 15 years in the industry, I moved to marketing, and then now I'm in communication. So there is always a hope to do something else. Don't worry. I'm also a pilot, but again, in your life, there will be always challenges, and today is a new challenge for you. Thank you.
Yeah, thanks to all of you. Unsurprisingly, a lot of pilots going around here. And then you can take a seat again, and then once the colloquia start, you can join us again. Thank you so much for introducing yourself. So, as I said, now we will move on to the challenge.
So the most of you know what the challenge was, especially the teams and the jury. So it was to combine 2- and 3-dimensional vehicle operations and to optimize the door-to-door travel concept of the future.
Yeah, as we all know, mobility as itself is evolving on so many fronts, and one of them is how we travel from our homes to other destinations, which involves currently quite a lot of steps, or at least it can. So one instance, for example, this morning I went by bus to the train station, and from the train station to another train station, took a second train, and finally arrived here at Messe Köln, and this was only a very short distance. If we imagine that we now want to travel abroad, we also have to get to the airport, where we might take another train to the plane or a bus on the tarmac, and then once you arrive at your actual destination, the whole procedure starts once again, only in reverse. So the challenge or the motivation for it was to simplify things a little and take out at least one of those steps. So we want, as it says, in more intermodal, also in the face of climate change, more environmentally conscious, and a concept that is closer to the user and to accommodate him better. We want your concepts to leverage new technologies, something that might not even be ready right now, but in the near future. And then, because EASA is also on the jury and part of this challenge, we would also like to think of the regulatory conditions, which are the basis for all aircraft operations.
So the challenge itself, the teams had to face was to create a proposal of operational concept and aircraft architecture, and they have to integrate mid-city and its airport in it.
Exactly. So we don't want to keep up the tension any further. So without further ado, we'd like to call into the stage our first team to present their results. So please, guys, come up to the stage. It is yours. You will get the presenter. They are from the Aachen Drone Development Initiative, another student initiative in Aachen. I don't know why that already skipped to that. But yeah, guys, the stage is yours. Have fun.
Okay, welcome. We have the honor to start the presentation today. As mentioned, we are the Aachen Drone Development Initiative from Aachen. First, I want this is the first page. Our concept name is air acceleration. And first, I want to introduce ourselves. My colleague is Ivo Sell. He is 23 years old. He studied mechanical engineering at the RWTH Aachen, and its main hobbies are model and sailplane flying. My name is Manuel Wustau. I'm 25 years old. I study aeronautical engineering in the Master of Science, and my hobbies are also model flying, but also FPV. Start with a challenge. First, we looked at the current state and the requirements and developments affecting the future transport systems frequently. The current transport, I'm quite nervous. Current transportation systems are often at the limit and lack flexibility. Especially the large number of time and nerve-consuming changeovers combined is contrary to call for time and cost efficiency. Additionally, the climate impact of traveling has to be reduced. Of course, the current person transport is reasonable for approximately 2% of the CO2 emissions, and the aviation sector, is 2%, and which has to be reduced by 75% following the flight past 2050. On the other hand, every new transport system has to be socially acceptable in terms of noise emissions and reliability. The feasibility of a new concept depends on the simplicity of the design and utilization of already existing technologies. Okay. The emerging technologies of electrification, digitalization, and small returns enable us a new thinking of transportation. Our goal was to combine these two new concepts, starting from this setting we defined as our main targets. Starting from this setting, we defined as our main targets minimization of changeovers and flexible employment of vehicles. Therefore, our main focus on providing seamless service, but still utilization in minimum necessary different vehicles. But despite all the great new possibilities, it can be considered impossible to have a vehicle that picks you up at your front door and carries all the way to your hotel, maybe in San Francisco. From a technical perspective as well as cost, and not to forget the airspace congestions. But how we can save these problems? The key points: minimize changeovers, flexibility and scalability. But this problem is actually not a new problem. We also solve this problem. For example, in cargo. For the cargo, the standardized ISO container has revolutionized the transport system and enabled today's enormous freight flows and globalization. More than 90% of all non-bulk cargo is transported with containers. It enables us to ship goods around the whole world without running into trouble changing the carrying vehicle. The container can swap between ships, trucks, and trains. And if you are in a hurry, also on aircrafts and even in helicopters. But a container is too large for operation. In cities and also requires too many people with the same destination to be efficient. Therefore, we adapted and reduced the concept to the absolute minimum, the seat for the passenger. I present you the Universal Passenger Loading Device, short UPLD. We use standard-sized pallets where the chair is on top These two are inseparable unit and carry all what you need. Under the seat is space for your small luggage, and in addition, we have an entertainment system on board. On the technical side, we have all the equipment we need for locating, tracking, and linking into the digital network. On the safety side, the seats has to meet aviation and automotive standards. The seating arrangement and number can be combined as desired. Here's an example of a bus for a family which would like to see each other. And here maybe application for sightseeing. And the nice thing is that you can easily operate even larger configuration. Here's an example for a single AL configuration, an airplane. Come more detail to our concept. The universal chair can be automatically interchanged between the different transport systems by using a coaster system. You automatically transfer between the vehicles of our systems. For example, you will automatically swap from the bus to the VTOL. I will discuss the individual application areas and ranges later. Moreover, it can be used in any size. As you can see in a bus, train, VTOL, top on the right, and future aircraft or even current aircraft systems. And integration into the existing system seems to be difficult, but it's quite simple. In the beginning, the existing infrastructure will be retrofitted step by step or replaced and supplemented by new vehicles, such autonomous buses or VTOLs. At the first, the passenger change the vehicle conventionally until sufficient system coverage is available. At this point, special hubs come into action, which take over the passenger handling. These hubs include the required swapping system. To fully utilize the advantage of the standards, to use the full potential of our passenger loading device, they can swap between all models of transportation. You don't need to combine it by yourself. This enables us to do changeovers fast and turnarounds even quickly. The flexibility results in possibility of responding to special needs of individual customers. As already mentioned, for families, for the businessman, in which time is simply of critical importance. Okay, but how look such a journey? I live in Aachen City, but my journey starts before I go out of the home. I'm booking one seat. This seat is for the whole journey, my seat. Then I will go out the door and pick up my autonomous bus. The bus, you use the bus in a range of 10 kilometers because it is such inefficient in this area to use air traffic, and the passenger volume is still too big. Yeah, I start here and go with the autonomous bus to our VTOL transportation hub. There I will be swapped to our VTOL. This covers a range of 600 kilometers. And also you can direct travel with our VTOL to our required destination. Maybe London or Paris. Yeah, but we like to go to San Francisco. We use our VTOL to go to the international airport in Frankfurt. And there we swapped also autonomous with our system in our long-range aircraft. It's also possible to use current airliners, but future technologies like hydrogen and high bypass airliners as well. Yeah, and there in San Francisco, you use also the autonomous bus to your hotel and you are there. But you don't need to avoid your short time to switch the vehicles. Yeah, and I like to take over.
Okay, I would now like to take a look at the now like to take a look at the new business opportunities and models that became feasible if you're using this networking approach with using standardized passenger loading devices. So first on the was tut das Ding hier? The most important aspect for the passenger or customer obviously is the time saving due to the shorter changeover times and less required changeovers between different modes of transportation. Furthermore, this network of small standardized units allows more flexible models. For example, you can choose priority transportation where the bus directly brings you to your final destination without picking up anybody else on a journey. Then you can, for example, leave one space beside your seat free to gain more space around you. So it's a completely new travel experience. Instead of walking a lot, standing a lot, waiting a lot, everything is basically automated for you. Then the process of buying just one single ticket for your seat from point to point instead of going to a bus internet page, an airline page, booking page, and so on, we just have one stop for everything. And the last, also not an important aspect, is that the networking effects should lower the prices and therefore make it more attractive to use the system. For the companies, on the other hand, they can participate in this network on many different stages, starting from vehicle manufacturers of the buses, the VTOLs or the aircrafts, over the operators of the vehicles, like airliners, all the way to the operators of the seats, provider of the booking pages, and so on. So current companies can either focus on their main business or expand to new regions in this network. Then everybody, especially the companies as well as the environment, profit from the higher utilization of the vehicles, because you can get a better capacity utilization, planning everything ahead. Then the reduced changeover times and high flexibility yields at higher customer satisfaction. The networking effect also supports the scalability. So you can start with a very small network and step by step expand it. And so in the whole process, the revenue for all companies participating in this network should increase. So after presenting our concept of the passenger loading devices, I would now like to focus on our connecting vehicle between the intra-city automated buses and the intercontinental airliner flights, our electric vertical takeoff and landing vehicle. We decided to use a vector thrust concept. This ensures a high cruise velocity and requires a low number of parts, facilitating economic operations. Electric ducted fans ensure good efficiency over a wide range of speed, starting from hover all the way to cruise. And the electric motors make complex control mechanisms unnecessary. The electric motors are supplied by a battery hydrogen fuel cell hybrid system. The hydrogen component provides the high energy density required for the medium range operations, while the batteries support the high needs of power density for the vertical takeoff and landing portion of the flight. The long-term goal is to enable autonomous flights. For initial flight operations, we consider a pilot necessary, which leads to a capacity of 4 passengers plus 1 pilot. In the long term, we plan to accommodate 6 passengers. Also, the very flexible cabin layout enables to transport cargo as well. For example, in a mixed passenger cargo configuration or for pure cargo flights during night hours. And also the cargo operation may be used to validate and implement autonomous flight before switching over for autonomous flight for passengers. We aim at a range of 600 kilometers with a cruise speed of 300 kilometers per hour. And a very rough first estimation pointed towards a maximum takeoff mass of 2.5 tons for a payload of 600 kilograms. Obviously, such a system has to be designed with the social acceptance and environmental friendliness in mind. So for the acceptance, for the safety aspects, we considered a ballistic parachute system as a kind of last resort measure. The per ducted fan, we're using 2 electric motors working on 1 shaft, so we have a redundancy. Each motor has its own controller, power supply, battery and fuel cell system, but they're completely separated. the avionics must be designed to interact with the still to be decided airspace structure and must be planned with the autonomous operations in mind. For the environmental aspect, we plan to use hydrogen as the power source, which is burned in fuel cells. The hydrogen is stored in compressed form in tanks integrated into the ring structure. And for the noise aspect, which is crucial for operations near populated areas, we decided to use electric ducted fans. And I have an example for you of an current propeller aircraft. And now an example of our current research at the IST at EUROPEAN Aachen, which are working on silent ducted fans. I think you have hardly heard something, and that's how silent they already have achieved these ducted fans. And obviously, the current airspace structure does not allow operations as laid out previously. To simplify future airspace integration, we plan to use fixed and pre-planned air routes. Communication between aircrafts provide every aircraft with a full situational awareness at all times. And the aircraft is integrated in the UTM system or respectively system for the lower airspace in the respectively area. And a detailed flight plan will filed ahead of the flight to cross-check with other filed plans to deconflict, if possible, already ahead of the flight. On the side of the Aviation Safety Agency, it is crucial that they provide a framework and standards for flights over densely populated areas. The air traffic control system has to adapt to the larger number of flights and also to the, in the future, hopefully, fully autonomous operations where radio communication in the classical way may no longer be the best choice. And finally, the certification process for VTOLs, electric, hydrogen aircrafts flying over populated areas with passenger, maybe autonomous, has to be laid down and fixed so that companies can work accordingly to this framework. Thank you very much, and we are looking forward to your questions. Do you want
Well, I think it's safe to say that you put a lot of thought into it. I personally have never seen a concept like it. It's really exciting. So now the jury, if they are ready, could once again, you can stay seated if you want, or once again come up to the stage. That would be up to you. You can use this microphone or the mobile one, how you prefer it, and then ask your questions, for which we will have once again 15 minutes time at a maximum.
Okay, so I go first. Is it working?
Yeah. Yes.
Yes.
Yeah.
Good. Then thank you very much for this very interesting presentation. It's the first time I see a concept using containers to reduce the time lost in switching from one transport mode to the other. So it's very innovative, it's new, it does not exist. So it's exactly what we are looking for in terms of innovation coming from students. What I've seen as well is that you are both coming from the engineering side of the business, but you were able to think about a business concept and to think about the use of it and to think about how to sell and how to commercialize the overall. So the question for me is about what you've presented, the blue design for the eVTOL and the previous different system. Is it pictures you have found online, or is it something you have developed yourself during the last 2 days?
We have developed it completely on our own in the last 1.5 days. So maybe you know OpenVSP. It's a free software by NASA, which is designed especially for conceptual aircraft design, providing all the parts you need to quickly design a rough concept. And for this kind of application, it's pretty nice to have such a software.
Okay, thank you. I don't know the software, but I see it looks very professional.
Thank you.
So I'm representing the EASA Safety Agency. Our business is to certify aircraft that are safe. You took safety into consideration when you've done the preliminary design. You mentioned a few aspects. You mentioned the dual control and monitoring system for the propulsion unit. You mentioned also 2 engines with 1 shaft to control and reduce the risk of total loss of. Have you think about battery safety? And more generally, in terms of rules and regulation, what do you believe an agency or regulator should do to protect public or to enable this type of product in the future?
I think the main problem of batteries at the current state is that there are not enough data for how safe they are. So don't have much data to calculate your expected failure rate, which you then could compare with, for example, the 10 to the power of -9 or something like this per hour. So at the current state, I would try to minimize the risk if a battery, for example, explodes or burns. And maybe this should also be like 2 options from the standardization framework. Either you can prove that your batteries are dead safe with doing, I don't know, 1,000, 1,000,000 tests of the cells itself, or if you can show that in the worst case of battery fire, it doesn't affect your aircraft performance and safety.
Thank you.
Thanks.
Yeah, thank you very much also from my side for the interesting presentation. I have a question concerning, from the passenger view, because, being a pilot, I see that you don't need me anymore in the future because it will be autonomous. So I would be a passenger. But yeah, I have to get used to the idea to be transported in a container. But what about, you made this example starting your travel in Aachen and then finally ending up in San Francisco. It's a good idea, but maybe there is only 1 person or maybe only 2 persons in Aachen who wants to go to San Francisco. So then for this case, you would have single person, what did you call it? Universal passenger loading devices? And how would it work?
So this is basically the smallest unit we have.
Yeah.
It's just 1 single seat. And so if you have only 1 person going from Aachen to San Francisco, then you maybe have another person going to China, another person going to London, another one going to New York or something like this. Then all these 4 people are sharing the same bus, sharing the same VTOL to Frankfurt, Cologne, Berlin, Munich, or somewhere else, wherever their flights are starting. And then are split off into their separate flights, where they join together with people from Cologne, Hamburg, wherever they come. So just exactly the same as with the sea containers today, where even with 1 single container with only 1 good, you can fill, if you have enough of them, a ship with 10,000 containers.
Okay. And then I do have another question to the ballistic parachute system. So I saw that you have 2 electrical engines per drive shaft. And why do you think you would need additionally a ballistic parachute recovery system?
For example, if you have, it was just as a kind of last measure. In case you have a total system failure, probably a collision with another aircraft that is not integrated into the airspace, like a sailplane or an old Cessna or something like this. It's not accordingly equipped.
But the plan is to recover the entire aircraft. It's not only to recover the container with the passengers.
No, it's like the Zero's SR-21 or Zero's Vision Jet
or the
parachutes.
Or the ultralight aircraft.
Sorry?
Or the ultralight aircraft.
Yeah, I think the Zero's jet is not really ultralight. It's 3 tons maximum takeoff mass. So the parachutes for this size of aircrafts already exist.
Okay, thank you very much.
Thank you.
Thank you, guys. Innovation is about thinking out of the box. So thanks for your presentation. Very interesting. First time I see effectively this concept of, let's say, seats, standard seats. Nevertheless, I don't have any question because I think they have raised more or less the issues. I will encourage you to maybe improve a bit on two ways. Customer experience, which is key.
Definitely, yes.
Yes. What is important is not how you think the technology should be. At the end, it's customer experience. And the second one is data, the use of data. Thank you.
Yep.
Thank you very much.
Thank you for your remarks.
All right, as this concludes the first group's presentation, we will continue with the second one. First of all, yeah, congratulations. It's amazing what you can do in only such a short time. We will quickly have to switch off the computer. I hope you will have an understanding for this. So this one you only need if you need audio. If it's only the video you only need the HDMI. And this one for the presenter if you want to use it.
Okay, thank you. Wait.
Hello. Am I audible?
I can do it. I'll do it.
Hi. Good morning, everyone. I hope everyone is doing great. So I'm Shubhom. I would like to introduce myself. So I'm Shubhom. I'm currently pursuing my master's in robotic systems engineering in EUROPEAN Aachen.
Yeah, and I'm Chirag. I'm studying at RWTH Aachen, and I'm doing my master's in computer-aided conception and production in mechanical engineering.
And along with all the well-wishers, we are called Trilogy. And going on straight to the point, to the problem statement that was given, we found out that the most important criteria that we wanted to focus on was door-to-door travel. That means once you get out of your house, you need to have a transportation. So, and we also wanted to emphasize on how to save time and risk management so that we decrease the amount of risk that is involved in intermodal transportation. So we came up with our own solutions, a hybrid vehicle that can actually traverse in all the three terrains, that is air, water, and land. So this hybrid vehicle, this hybrid vehicle consists of all the three. It is capable of all three transportations,
Yeah.
and
So, speaking about our concept, essentially we have come up with the concept which we'd like to call it as velocity. It's essentially an integral solution to our problem statement wherein we are integrating all the three types of means of transport. So we have water, we have land, and we have means of transport via air. So in land, we have essentially bikes and cars. So we have established that with our model, as you can see down. And when it comes to air transport, there are helicopters and aircrafts, which also by means of a concept we have integrated. And finally, to move on, we have water, which again I feel is quite important. Maybe while going in short distances and stuff, we can use water as a means of transport and need not carry forward through a boat or something. So boats and hovercrafts, that also is covered by our concept. So yeah, moving on.
So I would like to emphasize on the three modes that are integrated into velocity. The first mode is the driving mode. The second one is the bicopter mode, and the third one is the hovercraft mode. So all the three are integrated into it. I would like you to notice the animation that's involved in the bicopter mode. That will be accordingly explained in the next slide.
So moving on. Now we're into the bicopter mode. What bicopter mode essentially is that it's a substitute for the air means of transport by our concept. So in the bicopter mode, I'll explain the working. As you've observed the video, I'm going to explain with the help of some pictorial representations. Now we have three mechanisms here. One is the tilting mechanism, one is the folding mechanism, and one is the fail-safe mechanism. Fail-safe has to do more with safety, but the working is mainly with the tilt mechanism and the folding mechanism. So as you can see, in the tilting mechanism, we have a couple of rotors that are attached to our wings, and they are able to rotate from 0 to 180 degrees and thereby produce either forward or backward motion in the air at times, or the upward motion by means of a 90-degree angle, and hence producing 6 degrees of freedom. And while we have the folding mechanism here, essentially what this does is we have the wings that are expanded this way, and they are coming back at an angle and then collapsing and falling back in place into a chamber, which obviously is sort of hard to visualize in a concept like that, so we weren't able to put it, but you get the gist, right? There is essentially a chamber wherein our folding mechanism just falls in place and stores itself right there. So it's almost like a car immediately the moment it goes back in. And finally, it's a fail-safe mechanism wherein if we are mid-air and something goes wrong, there are a lot of catastrophes which could happen. So in such a case where we have lost complete all of our rotors, then in that case, immediately there is a parachute that is deployed, and before it is deployed, our vehicles begins to bank a bit towards the bottom, and the parachute ensures that it falls towards the surface at a very gradual pace. So that's the concept. And there are some specs, just so that you get a gist of what we are trying to represent quantitatively. So in the bicopter mode, we have a maximum speed of 300 kilometers per hour, a battery capacity of 85 kilowatt hour, a range of about 250 kilometers, and a payload of maximum 400 kgs. So essentially what this concept does is we are trying to pitch it to people of small groups, like let's say families of, like let's say 4 members, or families of 2 members, 3 members, something of that sort. So yeah, that's the idea. Moving on, I think Shubham will.
Yeah, the second interesting part of this is the hovercraft mode, wherein if you can notice, there's a cavity inside at the bottom part. So once there are 3 mechanisms in order to explain this. That is the inflate mechanism, deflate mechanism, and RPM variations. So once it is deflated, it's safely stored inside the cavity. And in order to deploy, if you could notice the animation wherein the turbine that is there in the center actually inflates it, and the cavity that's there in the between starts to throw out the wind aside, so creating an air cushion effect, so that this becomes an hovercraft, and this the rotors now are aligned at the 0-degree angle, so that it starts acting as an hovercraft. And so by varying the RPMs of the respective motors, we can actually get the angles that we want to turn our vehicle into, like if a proper hovercraft functioning. And in this hovercraft mode, the battery capacity remains same, the range is 150, the speed decreases to 60, and the payload remains the same. So this is the hovercraft mechanism. Next.
Yeah, moving on. So I'll be explaining the driving mode. This is essentially like back to basics, wherein we are using our vehicle, a concept, to travel along the roads. So that's what the driving mode essentially is. Here again, we have like 2 basic mechanisms. One is the rotor lock mechanism, and the other one is a folding mechanism. What the folding mechanism does, as before I'd mentioned, the wings essentially collapse up, and then fold towards the back. And now we have our rotors, yeah? It cannot be in an open position. If that happens, then we are no longer able to collapse it into a chamber. So we rotate it, bring it to a required angle such that it fits right into our chamber and sits right in, and we're ready to drive the car. Yeah, and the specs are right below. So for the driving mode, we have a maximum speed of 260 kilometers per hour, a battery capacity, it doesn't change, it remains 85. And the range, we have a max of 500 kilometers and a payload of 400 kilos. Yeah.
So the most important part is nevertheless the safety that we have to take care about. Safety along with sustainability. So when it comes to safety, we have to see in all the 3 modes that we have designed. So when it comes to driver mode, we have crash detection, wherein as soon as the crash is detected, the nearby hospitals are all alerted and accordingly the GPS location is shared so that the location wherein the crash has happened will be detected and accordingly shared. The airbags and the air cushions that are integrated into the systems are automatically deployed on detection of a crash. This comes in the driving mode, and in the bicopter mode, as we have mentioned, the fail-safe deployment and also called as the parachute deployment, the airbags and the fall detection. As soon as there's a fall stall detected, our vehicle has a normal pitch down motion, so that it pitches down and accordingly the rear comes up and the parachute is deployed. And in hovercraft mode, the safety jackets are also included inside, so that in case we are stuck in between, we have safety jackets, and the SOS signals are also transmitted. The headlights of the car also works as an SOS signal, so that the nearby ships, if at all you're stuck somewhere, get to know that there's an SOS signal being sent. And even the nearby ships are also accordingly contacted for sharing the GPS location so that they can come and help us at the right point. And when coming to the sustainability, we have to take care of our nature, and hence the charging stations that we have we think of implementing will be powered using sustainable sources like solar powered or wind powered. And in future we also we also want to implement hydrogen fuel cells that can be used to charge the lithium ion batteries, and so that we have a renewable source. So, and we make sure that the sustainability is maintained, and the power dissipated when the lithium ion batteries are used. So using the coolant like glycol or any similar coolant, so when this gets heated up and it goes to a radiator, this heat can also be reutilized into the car's mechanism, so that we can utilize it and charge up the battery or any other similar components in the car.
Okay, so here we come to a business model essentially. So what we're doing here is we have two ideas in mind. So one would be to go ahead with an independent venture, and other one would be a joint venture. I'll come to joint venture in a bit, but I'll explain what independent venture is. It's essentially an idea wherein we ourselves are setting up our factory and we are producing our own cars and then integrating different components into it. So for example here, as you can see the pie chart here, the 3D pie, what is happening here is this represents my total selling price. And in that selling price, we have different components, which would be the raw cost of all the things involved. So let's say the car, the hovercraft, the rotors and wings, then the miscellaneous costs. And finally, we have obviously the selling price minus our raw cost will be the net profit, right? So that's what is being added as the bigger pie, and eventually gives us the selling price of 283,000 euros. Now, over here, essentially what I've mentioned is the initial setup cost, which represents the cost which is required to set up a factory, get in laborers, and things of that sort. Set up a proper, organized system in place to get things moving. Then this is our assumption that the number of cars we will be producing per year will be around 300 numbers. But note again, this assumption, obviously when we start our business, it's not easy to start away mass producing 300 cars. So what we are assuming here is, during the course of time, over an average, it comes down to 300 cars. So now the average is 300 cars per year. And as you can see, there are two lines here. One would be the blue line and the orange line. The orange line essentially refers to the total money made out of the cars that have been sold up to now. And the blue line essentially represents my initial setup cost and the raw material cost that has been put into place. So as you can see, at some point, the total money I have made out of selling would break even with my raw plus initial costs. So that essentially is what we have represented by means of this graph, wherein at around the 12th year, we have reached a break-even point, and we're now able to move forward in a better state. Yeah, and moving on. Now, the second idea that came to us is the idea of joint venture. The reason why we came to joint venture is because in the idea of independent venture, what happens is the number of years involved is very high. We are taking 12 years to almost reach break even. But here, as you can see, we are reaching in about 5 years. Now I'll explain what joint venture is. What we do here is we do not make the cars. The cars are already made electrically by, say, Tesla, Mercedes, or BMW, or someone. What we do is we use these cars. We approach those big brands, and we use their cars and modify it with our components. So here we have removed out the car component and the hovercraft component, and the rest of the components make up our 3D pie. So that's essentially the rotors and wings, the miscellaneous costs, and the profit. That would be our selling price. So now what we're assuming here is we still need an initial setup cost of about $1 billion. And the number of cars we are assuming over average would be about 300 cars would be modified in time. And so as you can see, the previous concept which I had explained, which is the total price, the total money made out of the car sold, and the raw plus initial breaks even at about 5 years. So we're drastically reducing the time we require to reach our break-even point. So those are the two ideas that broadly came to our mind, and we thought maybe one of these ideas could be the way forward for us.
So one more point is, I do like to mention it. As the industry increases and it becomes faster, the number of car produced also might increase as usual. So since this is a new venture, so that's why we kept the production at less as 300. But as the year passes by, we might increase, and the selling price also might decrease as we produce more and more. Whatever the profit is generated, we like to invest it back onto our company so that we eventually expand and decrease the selling price as well. So finally, ending up with the conclusion. So the model that has been presented, a miniature version, was actually tested, and the results was tested by me, and accordingly the results were promising. So that's why the extra, the hovercraft and all were later inculcated. And since the miniature version was promising, so I feel that the model that has been presented is trustworthy, and it's promising in over years. And further analysis on the model would help for a better modification and testing. The business model has two models, so that whichever model is more convenient could be inculcated and accordingly proceeded. We can also stress upon service revenues. So service revenues like rental, so decreasing the price drastically so that we need not buy it, instead we could rent it. And car upgrades, accessories, charging station, car maintenance, these are all the side service revenues that can be inculcated, so that the break-even point will still reduce by a lot big margin. And various other when it comes to sustainability, various other fuel alternatives are also considered. So over in due course of time, we think we're thinking of inculcating some nice fuel alternatives that are more sustainable for the future. So this was our presentation. Hope we did good. Thank you.
Hope you guys enjoyed it.
Thank you all.
So, thank you very much for this very interesting presentation. Challenging times ahead. Maybe I missed the point, but I think your vehicle will be fully autonomous. Or is there still a driver, a pilot, a captain required?
Yeah, so we are aiming for an autonomous vehicle, but initial stages would be more practical to have a pilot. So eventually, in course of time, it will become autonomous, because the people around wouldn't trust the autonomous feature of the vehicle initially, is what we feel, in due course of time, in case we inculcate it within few years. So as we proceed year by year, we inculcate autonomous feature as well.
So the size of the vehicle, it looks like it is designed for a family.
Yes.
So it's for private use.
It's
not so much for commercial use. So meaning the individual who is going to use it would have the need to have these licenses, for example.
Yes.
So driving license is clear, but also pilot license. and later on also naval license if you want to use the sea.
Yeah.
Did
Yes.
you take this cost also into calculation?
In the service revenues, we actually had this point as well, but we were thinking more towards autonomous feature so that it would be easier for the families. They need not do train themselves. We also had that one more point wherein we used to give driving trainings
Yeah.
so that the normal any member could get used to it and accordingly fly it later.
But obviously, there's a huge proportion of the autonomous technology that we would like to inculcate. So, even if we start off, obviously it's not 100% autonomous, but at least 60 to 70% we would like to make it assistive so that there are very less chances of the human error that is possible. Because obviously, you or me, I mean, you or someone or him, for example, if he has to fly a normal, let's say, a vehicle like this, there's a very high chance of an error, right? So that's why we were thinking of putting in assistive technologies and then slowly developing. And
So
one of the service revenue points also which we were thinking was of giving people classes.
yeah,
to-
and as of now, level 5 autonomy is still not. It's very far in future, is what. So we need time for that to come in action. So till level 3, we could implement into it. So any level 3 features could be inculcated into it, is what I feel.
Thank you very much.
Thank you for your presentation. One question on my side is about the car. If you are on the road with this vehicle and there is a lot of traffic,
Yeah. So this
See,
this.
Go ahead.
Okay, so in the driving mode, we made sure that the side the rods that are there gets folded up and it becomes, it portrays itself as a normal car. So the whole mechanism that's there, it's all inculcated inside the rear end of the vehicle, so that it doesn't hinder into any other mechanisms and it doesn't look that bulky as possible. We try to make it as similar to a car as possible.
yes, but if there is a lot of traffic on the road,
Yeah. So in case if there is a lot of traffic in the road, we could go to a free spot, take a detour, and probably take it off immediately and go to our destination.
okay. Thank you.
Thank you. Thank you for your presentation. I've seen you've put a lot of thinking into the aircraft, car, and boat to mix the multimodality and to meet the requirements from the question on multimodality, which is great. But then the risk will be that you will have to comply with a lot of different regulations. You know, aviation is a very regulated market, and it's already complex to design an aircraft. It's the same for a car. So then you will have to deal with different type of requirements, different communities. Have you thought about this type of risk, the legal risk, and what is your opinion on this aspect?
So I feel as this technology comes into action, it will be looked over. I mean, it has to be, the regulatories might change in future because it it uh, it it do feels that in future these would become more common and each and every family would be airborne. So that's the feeling that I have, and accordingly the regulatory the frameworks might change to support such a future.
And
Is what-
maybe there is maybe a possibility that they could open up just some part of the airspace in terms of the altitude, maybe for this kind of transportation. That's what I maybe in the future maybe there is a possibility like that because
and
yeah.
Yeah, and even if at all it becomes autonomous, it would have its own features like it would be aware of the surroundings, and once an altitude is given to us, so that we communicate with the nearby vehicles that are similar in features and accordingly get their locations and make sure that it doesn't collide and proceeds safely in the given altitude.
Okay, thank you. And I want to follow up on a question from Airbus, who mentioned on the first team that they are looking to sell customer experience and also data. So have you looked at the data aspects and as a car, aircraft, and boat manufacturer, what type of data will you collect or analyze or sell?
Yeah, so in for this type of vehicle to become autonomous, data is the most important part of the vehicle. So there is always a data link communication. Like it does support all the 2.4 gigahertz. It does have a satellite communication. It does support LTE, and thus the data is continuously being shared between the vehicles, between the station wherein the primary communication is happening, and it also would have its own data collection memory integrated into it, so that we could easily access it. Because if at all there is any error that happens, it is important that we take care that it doesn't happen again in future. So yeah, data has to be collected, because autonomous features, if at all they have to be inculcated, we have to make sure that there are more vehicles running and more data is collected.
Okay, thank you. And one clarification on the business case you presented. So I understood the revenue will come from the selling of the products, but you will not have parallel review stream coming from maintenance, spare parts, or any other type of services or activities.
No, that comes in the miscellaneous costs.
The miscellaneous cost that
Yeah,
is included into
that
it.
it comes under that. That's what I meant by the term. The yellow bar that you see there, pie chart, that is essentially the miscellaneous cost. So that sort of includes all that
I
stuff.
was not looking at the cost, I was looking at the revenue.
Ah,
The revenue you will get from the operation.
Yeah, so
Yeah.
the profit is what. Yeah, so the profit generated, usually we haven't subdivided the profit, but yeah, if at all we are considering it to the has the revenue generated, it will be subdivided into various parts according to the needs of the company. We were thinking some of the profits will be invested back into the company, and some of it will be whatever the initial setup, the amount that we used to set up the industry, it will go back to it and accordingly clear up the debts that is pertaining to the industry.
Okay, thank you. And my last question is the same I asked our previous team is, have you designed yourself the picture you have presented?
Yes.
Yeah.
And you use the same software, or which
We
tool
use
have you-
SolidWorks.
SolidWorks.
Yeah.
SolidWorks. Okay.
Yeah.
Yeah, so it's this whole thing was done within 1.5 day.
Yeah.
Yeah. So that's what that was one of our issues when we were trying to present you the folding wing and going into a chamber and stuff. That required more time is what we felt, and that's why maybe some of the questions were raised regarding it. So yeah, we tried to put as much effort as we could. And try
Thank
to
you very
come
much
to
for your
something.
work. Thank you for the presentation.
Thank you.
Thank
Thanks
you,
a lot.
Thank you.
Make sure to put in the. Thank you. So once again, we will have to change to the other device. Yeah, now it's obviously on the wrong part, but if I restart it, we might be able to see it. So yeah, there you are. You have the presenter. Perfect. Then you can try it out, and if you want the microphone, hey.
Hello, ladies and gentlemen. Well, hello, ladies and gentlemen. I hope everyone can hear me. We are going to present you Atmosphere's our Rotorbumble. The team is made up of Tobias Welch and me, Leonardo Diekmann, and our since our problem was how to move on faster, we wanted to get a solution to move faster from door to door from a place where you want to be. We took as an example from here to Mykonos, because a friend of you might invite you to a party on Mykonos, or maybe to a vacation or to a congress, whatever it is. And usually you will have to go to the train, you will have to take the train to the airport, pick the plane, and this all costs time. In usual, they tell you to be around 2 hours before the plane leaves the airport there, and you will have to walk a lot, you will have to have some issues because there's the security, there will be lines, you might even need more time than you actually needed if you could get closer. So our system is you would get picked up by our Rotorbumble, and the Rotorbumble would get you to an access point quite close to your plane where it is going to leave. It would have a separate port for security checks as well as the regulatory necessities. And if you get into the plane, the same procedure is going backwards, so you will be left at the home of your door. The usually when you check in, it is more like you go there, you have to give up your luggage, you go to the security gates, you will have to board, and then you're finally able to fly. With our system is you get close by, you will have a separate security gate, so we will take care of your luggage. We won't let you put the luggage into the airplane, so we will take care of that, and you only will have to get to the security gate. And since you're located close to the plane you're leaving, you will be right able to enter, which will improve the timing and also the time cost efficiency for some businessmen.
Yeah, so this is our Rotorbumble. So we call it Rotorbumble because it is modular, and the top part is called rotor and the bottom part is called bumble. So when it flies as compact, it's Rotorbumble, and then it's flying just the rotor part, it's called rotor. And yeah, it's special because the rotor part is flying autonomously, and it consists of 5 rotors, which are in a circle around the center. And we said we want to use 5 rotors because the center of the gravity is not in the center of this circle for the rotors. So one has to be less strength, and the 4 at the bottom, at the front, has to be stronger. So as you can see on the right, we have in the upper part our motors, 5 rotors, and a tank. So what is that about? The motors are electric motors in every rotor in the middle. So we have 5 motors. So in case of the failure of one rotor, there are 4 rotors left, and the electric energy is split up to the left 4 ones. About the motors, we have considered hydrogen propulsion, but burned in fuel cells, and then the electricity is powering the motors, but I come to this in a later slide. As the rotor part is flying autonomously, it has to have a tank. It has a single tank at the top, and we said it's not important for redundancy, because if the rotor part is failing, it's no damage to people or whatever. So it's just an loss of our vehicle, but nothing important. So let's come to our bottom part, the bumble. There we have mostly our payload or passenger, which we are thinking of. So it's an elliptical shape, so there's space for the passenger, which we calculated for 100 kilogram, which is a bit more than common passenger calculations, because we think that the people who are using this might be a little more heavier than the average. For example, some businessmen might be heavier than the total family flying in a plane. So this is why we considered 100 kilogram for a person and then 20 kilogram for luggage. So this is when we have a single seater in here. But we can have a two-seater as well, so then we have in total 240 kilogram payload. And it's very important to have redundancy for the safety. So this is why we have a second tank in our bumble part. We consider that at the back of our bumble. Important is there to say that we considered no parachute as our fellow students does. We think that our vehicle in total is safe enough because of many redundancies at the top and especially for the tanks, and we think that's enough. Let's now move on. So what is important? Our business case is to bring important people to the next international airport to then fly to another airport and then get transported by our rotor bumble to their final destination. So how far do we have to go? In Germany, it's pretty crowded, many international airports around the country, and we have shown a circle in a radius for 100 kilometers. That means that I can reach every international airport in 100 kilometers. But the problem is, what about Greece? We want to go there, so it's a bit more, we have a lot more islands, and the next international airport could be a lot more far away, even if I have to take a ferry or whatever. So we have again shown a circle with a radius of 100 kilometers. We just pointed in the middle of nowhere, I would say. So as you can see, you can get within a 100 kilometer to the next international airport. So it's no problem to get our destination in Mykonos. It has an international airport, so the range would be that far, but you can go wherever you want.
Of course, we spoke about the transportation between airports and the homes we're talking about, but also an option that we might be able to land on top of gas stations. We thought about that because gas stations are usually private, and since private property might be allowed to, due to safety regulations, we might be able to park our vehicle on top of the roofs, which enable us to also refill hydrogen in necessary needs. So that's why we think that every gas station is also an opportunity. In the last 10 years, there were basically only a handful of gas stations all around Germany, and they have planned that basically every gas station, which is now on the for me it's the right side, for you it's the right side, that basically every gas station is going to have an port for hydrogen. So even if it is not that our rotor bumble might not be able to solve the 100 kilometers, that we might be able to park it, refill the gas, and then take off again so that we get the person where he needs to be as fast as possible.
Yeah, it's my turn again. Okay, I take this off. As the groups before, we considered some data. As I said, we have a range of 100 kilometers and we want to reach our next international airport in 1 hour. This means we have to have a cruise speed which is 100 kilometers. I forgot lately that our minimum passenger capacity is one, but our maximum is 3. So we have this modular bumble to connect it to, or we have different bumbles to connect it to the same rotor, which means that you can take different bumbles to fly to your destination. So for the biggest one we consider, we have a maximum payload of 360 kilograms. This is, as I said before, for an average businessman who might be a bit heavier, maybe 3 people, but if there's a family, there would fit in 4 people, so 2 adults and 2 children easily, including luggage. So statistically, 1/3 of the maximum takeoff weight is the payload. So there we get our maximum takeoff mass, which is around 1,300 kilograms. And to take some aerodynamic assumptions like drag coefficient of 0.5 into account, we get a maximum energy demand of 1,517 megajoule for a 1-hour flight. And then we want to be sustainable, and which is really important to reduce noise to the environment, so reduce emissions in total. So for us, a combustion with fossil fuels were not consistent because even all industries at the moment want to fly green. For example, the EU said we want to have the Green Deal until 2050. So we took into account an all-electric propulsion, and hydrogen propulsion with fuel cells, and a hydrogen combustion. To show you how we decided, we took into account the efficiency and the weight of each parts. So for the battery, for the all-electric system, we just have the battery, so energy storage system, and the electromotors. The efficiency is in total pretty high, which is good. But if you can see, the batteries would be very, very heavy, so even heavier of our vehicle itself. So we crossed it out pretty early, but we thought about that, but that's it. As a notation, all numbers are calculated with common data, so the technologies we use are in use today. So that means if you talk about entry into service, we can start building tomorrow if you want. But then back to our propulsion systems, we considered hydrogen and fuel cells. So we calculated our hydrogen, which is about 20 kilograms for a 100 kilometer mission in total, so for the maximum takeoff mass, and then use the tank mass and fuel cells and electromotor as you see here. And we get a total efficiency of 55% and a mass of 150 kilograms, which is pretty equal to the hydrogen combustion weight in total. But as you can see, the efficiency is pretty low in comparison. This is due to the combustion engine, and as you all know, there might be emitted some NOx, so this is why we crossed out hydrogen combustion as well, and we focused on hydrogen fuel cells.
Thank you.
Yeah, thank you very much. I hope you enjoyed your flight with Rotor Bumble and you arrived at your destination in Mykonos well. Thank you.
Thank you for the presentation. Quite interesting to see this new concept. So you are targeting one-man personal travel, right?
More or less.
Heavier man, as you mentioned, you are planning for 100 kilo, which is nice. You have not told us too much about your business model behind what you are planning to sell. Are you selling aircraft? Are you selling services? Are you selling experience or data?
That's the thing. We can sell basically everything. You can choose to only buy a bumble. Then you would have an opportunity to pick up to get a service that the rotor is coming, picking up your own bumble, and will get you to the next airport. We could also have a service system that when you want to go from your home towards your airport and so on, that you might choose to go to the next gas station, because as you saw on as you saw on this page, it's really crowded when it comes to gas stations, and it hopefully will be that hydrogen is going to be in common use gas instead of benzene or diesel. Once that also might be an opportunity that you are able to get to the gas station, take the bumble from there towards the airport, and so the ways with the bus will be shorter, or with a car or whatever. You take as a transport from your home to there, and
Shall I continue?
yeah.
So what we basically want to sell is the whole flight. So normally you take a plane in the first class, but it's from airport to airport, but it's not from door to door. So this is the case we want to sell. So to be fast and to be smart and to be efficient from door to door, which includes, of course, the first class flight in your plane, but also the flight with our rotor bumble from door to airport and back.
Okay. And on your overall concept of operation, I understood that the rotor part can be disconnected from the bottom. So it means you will have the rotor, which is self-sufficient with battery, with your own propulsion system, and autonomous, you say.
Mm-hmm.
So I think it will be able to move alone, go away, and another come back fully loaded.
Mm-hmm.
So it means as part of your operation, you will have to have a base somewhere with all these rotors will go alone and charge
Yes.
themselves.
Yes.
Can you tell us a bit more about this part of the operation?
That would be. It matters if if gas stations also would be interested in offering rotors or not. If gas stations would also offer them, they would have only to maintain the rotors. So basically they choose to get a fixed parking place for those. So they park themselves there in like stakeable parking lots, and the rotor itself would just hover out and get to fill himself up before picking yourself up. Or for the airport appliance, that it will wait on the airport, get refilled, and then move towards the destination or to pick up the target.
Thank you.
Yes, thank you also from my side for the presentation. So I understand, so this is a means of transport to get from home over some short range to the next airport or to any other point in the city. So that's belonging to urban air mobility, more or less. So what do you say, what's the advantage of this system compared to existing systems we already see here?
Well, since you're able to take the flight velocity into account, you probably are on this short range sector, you are way faster than usually cars or trains are. In normal, if it's a medium range, it's might be I don't know, it could be faster by car, but it's always like that when you are not sure because of traffic and so on, and you have an urgent a meeting or something like that, and you're just being picked up, you're being put out really close to your destination, and afterwards it's just 2-3 minutes away. And
my question was
Okay.
going in this direction. You see, we have this volocopter behind us. So what is the advantage of your system compared to this system?
Our system is modular. This means we can connect every bumble or payload or whatever to our rotor system, so we can, transport a lot more different parts and different components than, for example, the helicopter can do.
Maybe as an example, if you are in the middle of nowhere in Greece. Oh, wait a second. When you're in the middle of nowhere in Greece and there might be no fuel on your way towards your destination because, I don't know, there is no airport around in 100 kilometers, then you can stop on a gas station, and it will only take the rotor which took you there will give the signal to a new one, and it will just exchange the rotor, and you will be able to fly again in 1 or 2 minutes if you have to go more than 100 kilometers, which shouldn't be the case, but if there is a case, then you might be able to switch faster, which will also improve your time efficiency.
Did you do some cost calculations? So what would be the price for a ride for 100 kilometers to go from my home to the airport with my family? So 4 persons in the bumble.
Yes, that depends because we have now, I think 1 kilogram of hydrogen is €9.50 on the world market. So that would mean that for 100 kilometers with 19 kilograms, that would mean that they are €190 only for the gasoline, including the costs of operation and
plus the cost of operation.
including the costs of module. Around about 250, maybe €400, depending on situation.
Thank you very much.
Thank you. In addition, I have only one question. Have you, maybe you don't show us, but have you in mind that if there is so many bumbles, what will be the air traffic control or the traffic regulation?
We don't think we will have too many because it's just for VIPs or for upper class because we said it's pretty expensive, so we think it's just for people who just want to pay.
So it's a kind of VIP service.
Yes.
I think the problem is really that for 100 kilometer, €400 for the normal person being is quite hard to pay. Of course, if it's if it's like an event, yes, okay. But in usual, you will take the other transport methods. It is really for only emergencies or if you have a really huge appointment because otherwise your company will lose $1 million or something like that, then you are able to get there faster than by usual meanings.
So if it is only a VIP service, let's say, my recommendation is be careful of the citizen acceptance of such a tool, let's say.
Okay. Thank you very much.
Okay, yeah, thank you.
Thank you. Well, thank you also to the third team with their rotor bumble. 3 vastly different concepts. Okay, you also already have a mic.
Thank you. I think these concepts were quite different, very interesting. Many of this I've never heard before. And yeah, I think we will meet in an hour and 15 minutes. So we can see who will win this challenge and who won the online challenge before.
Yes,
And,
because we actually already have some people from the online challenge there. Just yesterday they flew in from Italy.
From
It's very
Bologna.
exciting, so great to have you here, guys. As Natasha hinted at 2 p.m. we will start with the award ceremony for both Rotorthons. So the live version which we just conducted here, as well as the online version. We are very excited to present to you the results. The jury will now retire itself to confer and decide what concept they like best with all the different dimensions that had to be considered. It's great to have you had here as an audience, as the jury and the teams. Thanks a lot for putting in the time, the effort, and participating today here at or in the last days as well at European Rotors 2021. Once again from Euroavia Aachen, from my side and
from my too. So thanks for your attention, but see you in an hour.
Bye.